Okay, now we're going to talk about thermal bridging. So this is another one of those thermal boundary subjects. And what thermal bridging is it's about if you have a material that's highly conductive, that energy passes easily through, and that material goes from the conditioned space on the inside to the outside space, then you have a situation where energy can transfer very rapidly from inside to outside. And we've gone to lengths now to create the conditions where the whole building envelope is like a thermos, that it's very good at resisting that transfer. But now we have a condition where at one point a lot of energy can be passing through. And there's a huge difference between how conductive different kinds of materials that we use are. The most conductive is steel. So we don't use a ton of steel, but in a condition where if we had like a big span or a cantilever deck and we were obliged to use structural steel, and if that structural steel went from the conditioned space to outside, we would have a place where a lot of energy was leaking out of the house. And just to give you an idea of how different the range is, steel conducts energy 1,600 times more readily than wood. Concrete also is a good conductor of energy, so although we don't have too many times when we have concrete that is going to be going from inside the conditioned space to outside, in buildings where you do have that, again, you have to have some way to interrupt that energy transfer. So the big thing in thermal bridging is to make sure that you don't create conditions like that, because it's really going to drive up the amount of energy that you have to use to keep the building comfortable. After you've made sure that you haven't made any big mistakes like that, then we get down to smaller thermal bridges. So this image here actually shows a conventionally built house, and you can see it's a thermal image, and you can see all these lines where you can actually see the studs. And what that represents is that the energy and the heat, this is a thermal image, so we're measuring the surface temperature. These areas are slightly hotter than the adjacent areas where we have the insulation. And then you can also see in this image that the window areas, the area where there's glass, there's even more energy transferring through. So again, we've talked about how once you make the whole pie smaller, some of the things that were small slices of the pie start to look bigger. So thermal bridging is one of those areas. This house, where we have exterior insulation, so not only are we going to have insulation inside the building cavities, which is the normal place that you would find it, but we're also going to have a layer of insulation outboard of that that's actually going to be attached to the outside of the framing. This is a practice that's becoming more common in residential construction, and in the future you're going to start to see more of this. But this, in addition to just adding more R value to the assembly, the other really nice thing about this is that it creates the conditions where you have a layer of insulation that passes over all these potential thermal bridges. So this other infrared image we have here is actually a house that we built about 8 years ago, and it was a certified passive house. In this image, you can see in the walls that you can't see any differentiation, so you're not seeing any evidence of a thermal bridge where the framing members are, and that's because there's rigid insulation on the outside of the framing. Another interesting thing to notice in this image is that earlier on I said that when you bought a good window and it had good glass, that actually you'd be getting more conductivity through the frame, and this shot here actually shows that in action, because we have a warmer area where the frame of the window is than where the glass is.